Hello guys, long time no see. I haven't seen you guys since what? The since we pick up our stuff at college, right? I have this one plan that I already planned with my family, which is we're going to make a birthday party. I've booked many things like the cakes, the balloons, and all the other stuff. Like there's many.
I figure out something that might tickle my curiosity. It's about the
Tickle your
balloons.
curiosity. What is it
Yes,
about? Is that?
Yes, what is?
it's about the balloons. I I always seen that people put balloons or some balloons inside balloons. Like there are many balloons inside a balloon. Do you get
Yes,
it?
Yes.
yes. I've seen that decoration before.
But I wonder something about the balloon. How can we calculate the balloon's surface area? Like if you want to put a balloon inside a balloon, we must know how much is the surface area for each of the balloon. But then if a balloon want to reach up to like 2 cm radius, how can it be calculated?
That is a really good question. Is that I might not be good at calculus. So what do you think, Daniel? Do you know how to do it?
It's quite hard for me now. I don't know. I think I know who can answer this question. Isn't your friend good at math, Azim?
Yes, I know him. His name is Aliff Zikry. Let me invite him to our video conversation.
Hey, hi, Alif.
Hi.
So, Izzat,
Yes.
regarding your question just now, how
Uh-huh.
about you ask Alif? I think he know how to answer that question.
I would like to ask you one question.
Yeah, what question? What?
It's about a balloon. You know, when we blow the balloon to make it big, I wonder if how much time do we need to make it, to make the balloon radius is 2 cm or 3 cm or anything. But I wonder how time can relate to the area of this balloon.
Okay, a question. You mean the radius of the balloon are getting bigger, right?
Yep.
Okay. So based on your question, I think the answer is to find the rate of change of the surface area. Is the radius is given? That the
Um,
is the question?
the question. Yeah,
Yeah.
yeah. I'll send it to you.
Okay. I will make the calculation for you. All right, guys. I got the answer.
Wow, really fast.
Yeah.
I told you
Okay.
that he's good at math.
Can you
Okay.
explain
So
it to us?
okay. Right. So the question is about to calculate the rate of change of the surface area when the radius is given 2 cm and the balloon that be expanded at the rate of 6 centimeter squared as to the power of -1. Do you know the formula?
Formula?
What is the formula?
Yeah.
What is the
Oh, you don't
formula,
know?
Aliff?
I think you know. All right, I will write it for you. I will send the formula to you guys.
Alright.
Wait. Okay, as you know, I write the given information at the upper of the page. So like the formula that I give to you guys, we just put the data. Okay, so the formula to find the value of A is 4 pi r squared, and the formula
Uh-huh.
to get the V is 4 over 3 pi r cubed. Okay. Next we do some differentiate. We must differentiate 4 pi 2r. Okay. Careful. Just differentiate the value or not the value. Just differentiate the 2r. So if we differentiate the 2r, we get r, right?
Yep.
Okay. So the answer is 8 pi r. And for the value of v, we just differentiate from 3r cube. So we get r squared, right?
Right. Okay.
Sorry.
Understand.
So when we
Understood.
get the value of the area and the volume, so get we just put it into the another formula to the formula is surface area per time. Like I write
Is this
dA.
isn't this the question rule?
Yeah, the question, yes. I use the question rule. Okay, so when we get the value of A and the V, we just put it into the formula, and
Ah,
you just simplify, and you will get 6 cm squared sec 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 power of -1.
Alright, today we're going to present about application of differentiation. So, in this group consists of 4 members, which is me, myself, Muhammad Fakhri Izzat bin Muhammad Khairi, and Muhammad Aliff Zikry bin Muhammad Farid, Kamal Azim bin Mustafa Kamal, and Danial bin Muhammad Azman. Okay, first of all, we're going to introduce you about differentiation. What is differentiation? Basically, we use differentiation and integration that can help us solve many kinds of problems in the real world. Basically, we need to use this is when we need to find the maximum and the minimum value. So we use other names than differentiation is derivative. So in this function, we use dy over dx, or in the same time we can use it as y prime or x prime. So when we use differentiation in real life, this is the example of why we use it to calculate the profit and loss in business using graph, to check the temperature variation, to determine the speed or distance covered, such as miles per hour, kilometer per hour, and etc. Derivatives are used to derive many equations in physics, and in the study of seismology, like to find the range of magnitudes of the earthquake. So we can see that it's like we kind of want to find about any maximum and minimum value of each method. So in this discussion, we would like to present our problem statement. So the problem statement is, as we discussed earlier, this is like the example of what we have been discussed. A spherical balloon is being expanded at the rate of 6 cm squared per second. Find the rate of change of the surface area when the radius is 2 cm.
Okay, the question about to find the rate of change of the surface area when the radius is 2 centimeter, and the spherical balloon is being expanded at the rate of 6 cm squared s to the power of -1. Okay, so we just write the given information right here. Okay, so we just put the formula into the paper. Okay. So the formula to calculate the area is 4 pi r squared, and the volume is 4 over 3 pi r cube. Okay. We just differentiate the value, the both value. Okay, dA per dt is means surface area per time. So we just put the both of the data into the formula, and we differentiate, and we get the answer 6 centimeter squared sec to the power of -1.
so the conclusion is from this topic, we can understand the first principle. We can also find stationary points of some functions, and then we can determine the nature of some stationary points by using the first and the second derivative, and we get to understand to work with derivatives as the rate changes. Finally, this topic can help us lessen our burden, our workload by applying the differentiation into our daily life.
So this is all our reference that you might might want to check it out to learn more about differentiation. So that's all from us. Thank you for watching our video. I hope you learned something about differentiation.